Next, see here the same thing, x equal to 2. Limit x tends to 2 minus. 2 minus, you reduce 1. See here, 2 minus, you reduce 1. That is minus. You reduce 1. You are getting the value 1. 1. 2 plus, you are getting the value 2. So, it is not equal. So, it is not differentiable. Now, we move on to the sum. See, we already seen what is the greatest integer. What are the values? If you are substituting there, what is the value? You have seen the graph also. So, now we are going to the sum. F of x equal to greatest integer x. First, I am discussing about at x equal to 1. At x equal to 1, I put it as left hand derivative first. Left hand derivative. Limit x tends to left hand derivative 1. F of x minus f of 1 by x minus 1. Then I change into h tends to 0. Limit h tends to 0. H tends to 0, left hand limit, what we have to write? F of 1 minus h by f of 1 by 1 minus h minus 1 plus 1 minus 1 get cancelled. It is, see here, in the place of f of x, it is a greatest integer x. F of 1 minus h, see it in the rougher column. F of 1 minus h, that is negative, 1 is approaching to 0. I told you in the previous example, 1 is approaching to 0. 1 negative means it is deteriorated. It is 1 is approaching to 0. So, f of 1 minus h, the value you can get it as 0 because f of x equal to x. F of x equal to x. F of 1 equal to 1, that is the integer 1.001. Okay, I told you because greatest integer 1.000, what is the value you are getting? 1. So, you will write it here. Limit h tends to 0. Limit h tends to 0. What is the value you are getting here? 0. See, 0 minus 1 by minus h. Okay. See here, which implies limit h tends to 0. Minus get cancelled. 1 by h. When h value becomes 0, 1 by 0, what is the value you are getting? Infinity. 1 by 0 is nothing but what? Infinity. Now, we move on to right hand limit. The same way you can write limit x tends to 1 plus, that is right hand value. F of x minus f of 1 by x minus 1. F of x minus f of 1 by x minus 1. See, what is the left hand derivative value we got it? Infinity. Okay, now we move on to right hand derivative. Limit x tends to 1 plus, it is nothing but right hand derivative f of x minus f of 1 by x minus 1. So, limit h tends to 0. F of 1 plus h minus f of 1 by 1 plus h minus 1. You cancel plus 1 and minus 1. See what is f of 1 plus h. F of 1 minus h is 0. Yeah, obviously you can say what is f of 1 plus h? Good. F of 1 plus h is 1. F of 1 plus h is 1. So, we are going to see here f of 1. I told you f of 1 value is also 1. F of 1 minus h means that 1 is approaches to 0. So, you can take it as the value as 0. So, if f of 1 plus h is that 1 is 1.1, 2 is approaches to 1. So, the value is 1. See, so what is the value for here? Limit h tends to 0. Limit h tends to 0. F of 1 plus h value is equal to 1 minus 1 by h. Okay. So, what is the answer you are getting? 0 by h. 1 minus 1, sorry, 0 by h. 0 by any number is 0. 0 by any number is 0. So, what is the value for that? You can write here itself. 0 by any number is 0. So, left hand derivative not equal to right hand derivative. Left hand derivative not equal to right hand derivative. So, left hand derivative not equal to right hand derivative. You don't write 0 by h. So, 0 by 0 form, that is indeterminate. Okay, you don't do like this. If it is 1 minus 1, 0 by any number is 0, you can write straight away. You don't write 0 by 0 form, infinity by infinity form, that is and all indeterminate. This is different, that is different. Okay, see here, left hand derivative not equal to right hand derivative. So, the function is not differentiable. So, the function is not differentiable at x equal to, is not differentiable. So, the function is not differentiable at x equal to 1. At x equal to 1. Now, we move on to discuss about the value of x equal to 2. See, now we are going to discuss about x equal to 2. First, you can see the left hand derivative. Left hand derivative, limit x tends to 2 minus, that is the left hand side, f of x minus f of 2 by x minus 2. So, what is the next step? Limit h tends to 0. Limit h tends to 0. Left hand derivative means f of 1 minus h minus f of 2 by 1 minus h minus 2. See, 2 minus h minus f of 2 by 2 minus h minus 2. Are we clear? Because what is the value of here? X equal to x tends to 2. So, 2 minus h minus f of 2 by 2 minus h minus 2. 2 get cancel. See here, we can see it in the rough work column. See here, f of x equal to greatest integer x. F of 2 minus h. What is the value you are getting? F of 2 minus h? Minus. 2 is minus because 2 is approaching to 1. 2 plus means 3 is approaching to 2. Okay. 2 plus means you are getting the value 2. If it is 2 minus means that is 2 is nearing to the value of 1. So, you are getting the value 1. So, f of 2 minus s, what is the value you are getting? 1. F of 2. F of 2, it's nothing but what? 2.000. So, what is the value you are getting? 2. Have you clear? So, it gives limit h tends to 0. Limit h tends to 0. What is the value? 1 minus 2 by minus h. 1 minus 2 by minus h. So, limit h tends to 0. H tends to 0. Minus 1 by minus h minus minus get cancelled. So it gives 1 by 0, the value is equal to infinity. Now we are going to discuss about the right hand derivative. We are going to discuss about the right hand derivative. See the right hand derivative. Right hand derivative, limit x tends to right hand derivative to, what is that, f of x minus f of 2 by x minus 2, f of x minus f of 2 by x minus 2. The same way, limit h tends to 0, limit h tends to 0, f of 2 plus h minus f of 2 by 2 plus h minus 2, 2 plus h minus 2. So plus 2 minus 2 get cancelled. See the value f of 2 minus h, that is negative side, left hand side. So 2 is approaching to 1. So you have to write 1. You wrote 1. See here, f of 2 plus h, f of 2 plus h. So what is the value here? If it is negative, you reduce 1. If it is positive, you write as it is. Because 3 is approaches to 2, 2.9999. So you are getting a value 2. Mind it, it is a simple. If it is negative, you reduce 1. That is 2 minus h. You reduce 1 because negative side, sorry, it is left hand side. The 2 is move on the left hand side, 2 to approaching to 1. So reduce to 1, it is the value is 1. If it is positive, positive means 2.999. So you write as it is the value 2. Whatever sum, you can do it in the same way. If it is 3 minus h, the value is 2. 3 minus h, the value is 2. 3 plus h, the value is 3. If it is 4 minus h, the value is 3. If it is 4 plus h, the value is 4. Have you clear? See, 2 minus h, you reduce one value, the value is 1. 2 plus h, the value is 2. 3 minus h, you reduce 1, you are getting the value 2. 3 plus h, the value is 3. Okay. So what is the value? F of 2 plus h is 2. What is the value of f of 2? 2.000, the value is 2. See here. So limit h tends to 0, f of 2 plus h, f of 2 plus h is 2 minus 2 by h. 2 minus 2 is 0. Don't write 0 by h, it is 0 by 0 form. The value is equal to 0. Straight away you can write the value is equal to 0. So left hand derivative you can get you got the value of infinity, and right hand derivative you got the value of 0. Left hand derivative not equal to right hand derivative. Therefore the function is not differentiable. The function is not differentiable. The function it is not differentiable at x equal to 2. At x equal to 2.